Okay, unlike question number 9, question number 10 is exceptionally easy. So the only real problem with question number 10 is trying to identify what you're trying to identify. So first thing you need is go to Google and find the equation of an arc. So find the equation for the area of an arc. An arc. Now you can, I guess you could, if this is pi r squared, right, for the radius, you can obviously get that from the equation of an arc, so it's not that huge of a deal. But essentially, and I guess simply put, for the area of an arc, you have, let's see, if this is phi, you would have phi over 2 pi times pi r squared to get to that area, if I recall correctly, right? Because phi over 2 pi is that ratio of the whole circle, and then I have pi r squared to get the area of the circle, so it's the ratio of the area times the area. So if I was a gambling man, I would say that this is correct, and I'm pretty sure it is. So essentially, we're asked here, what's the reach if it's omnidirectional? So we're looking for let's see, what's an easy way to see what we're looking for? Maybe he says it flat out. Assume the transmission. Okay. Assume the transmission energy required by an antenna is equal to the coverage area. In an idealized setting, this means that an omnidirectional antenna of range R transmits over the disk centered at the antenna radius R, while a directional antenna of beam width phi and range R transmits over a circular sector of angle phi in a circle of radius R. Okay, let E be the transmission energy of the antenna. How far can it reach if it's omnidirectional? Okay, so let's look at the omni. E be the transmission energy of the antenna, so this is E. In other words, the energy is the area. Pi r squared. We're asking how far can it reach, so we want to solve for r. So r is equal to the positive root, right, of E divided by pi. Okay, why is it the positive root? Because I can't have a negative radius, so we can ignore the negative part of that. So that's pretty simple. So here's our function of energy. So I can say R of E. So if I want to know the range, I have some energy, I divide it by pi. Done. Same thing for this, but instead of pi r squared, we say that E is equal to phi over 2 r squared. Now I want R, so big R is the square root of 2e over phi. Again, it's the positive root, and I'm done. Okay, simple question. Take the area equations for these two things, the sector, the circle, and come up with their R of E, right? So just rearrange the area equation, and then you're done. And that's the end of assignment A. So I think I'll probably film assignment B and C at the university today. So I'll see you all later.